Welcome to this video series about collets. Collet knowledge is very important because knowing how to use your collets properly will extend tool life and increase the quality of your finished parts. So, how can we make sure the collet is working correctly? We're going to cover collet basics, the difference between OZ and ER collets, essential maintenance, understanding the collapse range for your collet, loading the collet into the spindle correctly, and how to correctly position the tool. Let's start with the basics and cover the correct collet language. The collet sits in the nut, which sits in the spindle taper. This allows you to quickly change the cutting tool in and out of the spindle motor. So let's talk about what the collet actually needs to do. The collet serves two purposes: to apply the maximum clamping force to the tool and maintain the minimum total runout. Let's talk about what both of those things mean. By clamping force, we mean the amount of grip that the collet has on the tool. A high clamping force will dampen vibration, allow for increased RPMs, reduce chatter, and decrease the chance of the tool pulling out of the spindle. The second thing that the collet needs to do is to provide the minimum runout. Runout is wobble at the tip of the tool created by the tool being out of alignment in the collet. This can change the effective diameter of the tool and decrease accuracy in your jobs. If you can achieve a small total runout, it means that all the flutes on the cutting tool will be doing the same amount of work, which increases tool life and creates even wear. This will also give you a better part finish, better accuracy, and reduce wear in the spindle motor bearings. In this section, we're going to talk about the two different types of collets that we offer, the OZ series and the ER series. So which collet is best for you? The OZ series is the cheaper solution, but the ER series offers some real operational benefits. These benefits include easier tool changing, better part finish, improved holding reliability, and the ability to cater for a wider range of tool shank sizes. We offer a range of different spindles to cater for different collet types. There'll be a table on the screen to display this, but if you wish to learn about this in more detail, please visit our knowledge base on our website. What makes the ER collet different? Both collets have slots to allow for compression, but the positions of these slots vary between the two. You'll note on the OZ collet, the slots start from the top and run down to the bottom of the collet. This means that as the OZ collet collapses, it only compresses at the front and not the back. This creates tangential clamping. You can see from the exaggerated orange zones left here that the clamping force only gets transmitted to the front of the tool. In comparison, the ER collet slots extend from both the top and the bottom. So when the collet nut is tightened, the collet compresses evenly onto the tool shank. We call this even clamping. There are four main advantages of the ER system. The first advantage is that they're less prone to jamming. This is because the even clamping means that the rear can compress and is less likely to get stuck in the spindle taper. The second advantage of the ER system is that it reduces wear, vibration and noise during operation. This is because the even clamping creates a smaller total runout. The third advantage of an even clamp on the tool is that less torque is required on the spindle nut to achieve the correct clamping force on the tool. This reduces the likelihood of the tool pulling out during operation. The fourth and final advantage of the ER system is that each collet can clamp a range of tool diameters. For example, this collet is an 8 to 7, which means it can clamp tools with a shank diameter from 8 to 7 millimeters. The OZ collets can only clamp the exact stated diameter. Now we're going to talk about collet maintenance, which actually will have the biggest impact out of everything we've discussed in this section. Firstly, it is important before every use to inspect the collet for damage. Collet damage can impede the collet's ability to clamp the tool, affect total runout, and potentially damage the spindle taper and nut. Secondly, it is important to make sure the collet is clean every single time you change it. Dust can accumulate in the slots, the bore, and on the faces of the collet. You can blow this dust away or use IPA spray to clean away any stubborn debris. Finally, we're going to talk about lubricating the outside tapered surfaces of the collet. You may find this surprising, but this will dramatically improve your results. Let me explain why. Lubricating the outside tapered surfaces of the collet means that when the collet nut is tightened, the collet will not twist inside the spindle taper. If the collet twists, this means that it won't be clamping the tool shank properly, which in turn will cause your run out to increase. The second reason that lubricating the tapered surfaces is important is that the lubricant will prevent surfaces from corroding due to moisture in the air. It acts as a physical barrier to prevent the moisture from being able to get to the metal and causing it to rust. The third and final reason why lubricating the outer surfaces of the collet is important is that the lubricant acts as a release agent and can prevent the collet from getting jammed in the spindle taper. I'm going to show you how to lubricate the collet. We want to apply lubricant to both tapered surfaces where the collet contacts the spindle taper and the spindle nut, but never apply lubricant to the bore, as this will reduce friction on the tool and reduce clamping force. So which lubricant should you use? We recommend using Molykote P40 as it acts as both a lubricant and a corrosion inhibitor for the collets. You can use any lubricant you like as long as it follows these three criteria. It does not displace under pressure as the collet is compressed. It has good corrosion protection and doesn't absorb moisture, and has good fretting protection, which means it prevents the tapered surfaces from binding against each other. I'm now going to run you through how to correctly apply the lubricant to the collet. You will need some IPA cleaner, a lint-free cloth, your lubricant, and a small brush. First, clean the collet with your IPA cleaner and your lint-free cloth. That should only take a minute or two to dry. Once it is dry, we're going to apply a thin film of the lubricant with a small brush. I'm going to apply the lubricant just to the outside of the collet, taking care not to get any in the bore. Make sure to evenly spread the lubricant around the circumference of the collet. Once you're happy that all the areas are evenly covered, you're ready to use the collet. Finally, we're going to load the lubricated collet into the spindle and wipe off any excess with the lint-free cloth. We should apply this exact same procedure to the threads on the spindle taper. Spray the threads down with the IPA cleaner. Wipe down the threads with the lint-free cloth. Apply a thin film of the lubricant to the threads. Load the collet nut onto the spindle. And wipe off any excess. If you've never done this maintenance before, you will notice a vast improvement in how the collet feels and performs. In this section, we're going to explain to you how to choose the correct size collet for your tool. There'll be some important information that you might not know. First, we need to find out the diameter of our tool shank. You can often find this etched onto the surface of the tool, or if that's faded or you can't see it, use a vernier caliper to measure. Next, we need to be able to identify the size of the collet. Again, this will have markings either on the front surface of the collet or the side of the collet. For OZ collets, there is no clamping range. You can only use a tool that has a shank size which is the same size stated on the side of the collet. This is because the tangential clamping design, as we previously discussed, will not allow for any gap. For example, you should never put a 6mm cutter into a 1/4 inch collet. ER collets are more versatile in the fact that they're able to hold tools that are slightly smaller than the size stated on the collet. The size stated on the collet will always be the maximum size the collet can take, as it will always compress down. For collets with a bore under 3mm, the clamping range is 0.5 mm, and anything over 3mm has a clamping range of a full millimetre. For example, a 2mm collet would have a clamping range of 2mm to 1.5mm, and a 6mm collet would have a clamping range of 6mm to 5mm. Sometimes an ER collet will have two numbers printed on it, which indicates the range of the collet. Sometimes it will only have one number. This will always be the maximum size that the collet can hold, and it will only compress below that. A couple of important things to note. You should never insert a tool larger than the maximum size stated on the collet, as this can cause permanent damage to the collet. Secondly, if, for example, you have a tool that has an 8mm shank and you have two collets, one is an 8-7 and one is a 9-8, you might wonder which one's the right one to use. The answer is you should always choose the collet with the maximum size closest to the size of tool that you have. So in this instance, you choose the 8-7 over the 9-8. This gives you the maximum collet to tool surface contact. In this section, I'm going to run you through how to load the collet into the spindle. It is important before you do this to make sure you've completed all of the maintenance tasks that we discussed in the previous section. I'm going to show you some helpful tips to make your life easier in this process. It is important to always load the collet into the nut first and never load the collet into the spindle and screw the nut on top, as this will cause damage to both the collet as well as the nut. When loading an ER collet into the nut, it is extremely important to note that the nut has an eccentric washer inside it. This means that one side, the washer is wider than the other. You can often find that a marking on the collet nut which will indicate where the widest part is. To load the collet into the nut, you take the recessed ring around the collet and load that at an angle onto the widest part of the washer. From here, you just push the collet and the other side will click into place. You can tell the collet is correctly inserted if you invert the assembly and it won't fall out. If you've got an OZ collet, the nut will still have a washer inside it. However, it is not eccentric as it is on the ER series. This means for the OZ collets, to load into the nut, you simply push in until you hear a click. Now we've loaded the collet into the nut, we're ready to insert the assembly into the spindle taper. This spindle is now ready for you to insert the tool. In this section, we're going to talk about loading the tool into the collet. It's very important to get the tool in the right place in the collet. There are two main things to remember when doing this. Firstly, the tool must be inserted a minimum of 2/3 of the way into the collet. If the tool is inserted a minimum of 2/3 of the way into the collet, this maximizes the contact area and the holding power of the collet. Secondly, the tool should never be inserted far enough that it is touching the spindle taper. If the tool is touching the spindle taper, this can knock it out of alignment and increase your total runout. Some tools will have what we call a K mark etched on the shank. The intention of this mark is that it should be lined up with the front face of the collet as a guide of how far to insert the tool. However, as I say, it is just a guide, and it is important to always prioritize the two rules that I mentioned before over the K mark. Number one, the tool should always be inserted a minimum of 2/3 of the way into the collet, and number two, the tool should never touch the spindle taper. Now we're going to talk about how to tighten the tool in the collet. To allow you to tighten the nut, you'll need to press the rotary stop button on the spindle, tighten the nut by hand, and then add 1/8 of a turn with the spanner. This equates to around 10 Newton meters, which you should never exceed, as this can cause the collet to twist and increase your total runout. As a final check, it is important to look at the gaps in the front face of the collet. If the gaps are open and even, this ensures that the collet is the correct size and it has not been twisted by over torquing. Thank you for watching this section on collets. I hope you've learned something useful. If you do require more information, there's links to knowledge-based articles in the description below.